All right, today we're in section 7.1, probability. So this is our first lesson that we're going to see on this concept of calculating chances and odds. All right, so we just had actually a pretty decent discussion on likelihood and probabilities and what would be a real life example of 0% or something close to 0% or 100%. And we've got a pretty good grasp on likelihood and probably thinking about probability in terms of like every day. We actually use it a lot more than we think. All right, so here's the scale, the probability scale, what I call the probability scale. All right, and this gives us, you need to write this scale on your notes. All right, this gives us a really good idea. It gives us the fraction value, the decimal value, and the percent value on the probability scale. Okay, it also gives us some keywords, and it's really important that we all use the same keywords. Okay, does anybody know what a synonym is? What's a synonym?
It's similar. It's like similar to a word.
Okay, a word that means about the same thing. Right? A word that means about the same thing. So we don't want to use synonyms here as much as possible because it just makes grading really difficult. Like you say, oh, well, that's what I meant by that. I meant unlikely, but I just said whatever, slim chance. Okay? Well, yes, it essentially means the same thing, but the more we kind of get into the synonyms, it's really difficult to make sure that you knew what the likelihood was. So let's try to all use the same words. Impossible is 0. Unlikely is 25%. Even chance is 50%. Likely is 75%. And certain is 100%. Okay, your book gives a slightly different variation to that. It's not that I'm going to count off, but if I'm not sure which percentage you're trying to describe, then I can't give you credit for it. All right, so let's try to all use the same terminology. And then too, it shows us again, and we saw this in the last chapter as well, a fraction, a decimal, and a percentage, and how 1/4 means the same thing as 0.25 and 25%. They all mean the same thing. That's important. Okay? If your weather guy said on the news, there's a 1/4 chance of rain today. You think that makes any sense to anybody? No. Probably half of Jacksonville doesn't know what 1/4 is either. Okay? But if they say 25%, that's what we can relate to. But we have to understand that they're all interchangeable when we're calculating probability. Okay? All right, so finish copying down the scale. Okay, in example 1, and I like what they're doing here. This lesson actually was not in your last book at all. It was kind of like more like 7.2 and what we're going to learn tomorrow. But I like what we're doing here. We're really trying to lay some groundwork for probability. Turn around. Okay, we're trying to lay some groundwork here and help you kind of wrap your mind around what does probability mean. All right, so I'm going to write a fraction up here that kind of describes probability in a nutshell. We have that probability, so I'm going to use the letter P, equals your favorable outcomes. If you remember nothing else about probability, remembering this could actually get you to a lot of correct answers. Favorable over possible outcomes. This is abbreviated, and you're going to see the full version of this tomorrow. But this is really our, you could say our targeted outcome is this ratio here. Favorable outcomes out of possible outcomes. So what we're doing in 7.1 is we're just trying to identify how many favorable outcomes do we have? How many possible outcomes do we have? We're really, in example 1 and 2, not even calculating a probability at all. We're just saying this is how many there are. All right, do you see what we're doing here? We're just training ourselves to kind of pick out what we're looking for. All right, so you spin the spinner. How many outcomes are there? All right, well, when you look at the spinner, what do you notice? What do you notice? Yeah, there are multiple numbers. So you'd say, oh, well, that only counts as 1. Technically, they do each count as an outcome. All right, now, changes the probability of landing on a, say, a 1, that would go higher because there are multiple possible outcomes, but each one still counts as an outcome. So basically what I'm asking is, how many spaces are on the spinner?
8.
8. There are 8 spaces on the spinner. That's all you have to do on your homework. What did I ask you? How many possible outcomes are there? 8. Done. All right, so you look at your homework and you say, man, she gave us like 12 problems. Well, they're
17.
short. There's not 17.
Yes, there is.
No. There might be 17. Okay? But they're short, they're quick, they're not actually calculated problems, most of them. They should be pretty quick answers. All right, so now look at the second one. What are the favorable outcomes of spinning an even number? So I'm going to kind of prepare you or set some groundwork for 7.2. Here's how we write probability. P for probability. And then in parentheses, I write my targeted outcome. What would be my favorable outcome? Well, it says it right here. Spinning an even number. So what is the probability that I spin an even number? Okay? So in parentheses, I write what my targeted outcome is, or my favorable outcome. So now I go back over to the spinner, and I identify which outcomes would be favorable. All right, so tell me the numbers. 2,
4,
6, 4, I just go clockwise,
4.
and 4. Okay, so how many outcomes is that?
4.
Okay, so if it said how many favorable outcomes are there, you would say 4. In this case, it said what are the favorable outcomes, so listing them would be my answer. You see that? If it said how many favorable outcomes, you would say 4. If it wants you to list them like it does on this lesson, you would list all of your favorable outcomes. So now let's look at the next one. In how many ways can spinning a number less than 2 occur? So I want you to try to write what would belong in the parentheses. What is your targeted outcome now? Try to write it in parentheses. And your writing may be a little different. Okay? Just get it close. Probability of what? Probability of what? Probability of a number less than 2. Okay? Probability of a number less than 2. All right, equals, all right, how many ways? Well, first I have to figure out how many of these results on the spinner meet the criteria. How many of them are less than 2?
3.
Not 2. 6, 3, 4, 4. How many?
3.
3. And they're all 1s, okay? So it's 1, 1, and 1, but that's not what it asked me. How many? So it's 3 ways. All right, so the wording of the question is important. When in doubt, just put them both, okay? But it is asking in how many ways, so you say 3 ways. So that's it for example 1, identifying outcomes. In example 2, we're describing likelihood. So we're going back to our probability scale. And it's important that we express these in complete sentences. Your complete sentences can look different. I'm going to show you a couple different ways that we could write a complete sentence. But here we're given some probabilities. There's an 80% chance of rain, 50% chance of thunderstorms, and a 15% chance of hail tomorrow. And goodness, wasn't that the truth today? Man, I'm surprised it wasn't hailing out there with all the rain that was coming down. But what I'm going to do is I'm going to use the specific vocabulary. Was it unlikely, likely, an even chance, impossible? What was it? Okay. So for rain, 80%. Which interval? 0, 25, 50, 75, 100. Does that one fall closest to? 75%, which is likely, very likely. Okay, I would take some deviations around that wording, but I would say because it's close to 75%, the chance is likely. And I want you to underline the word that you use as your keyword because that just makes it easier to grade. I see likely, it jumps out at me. I know it's a complete sentence and I know you got it right. Okay? It's likely. If you say impossible, that is wrong. Okay? 80% is likely. And I think that's about what it was today, 80-90%. And boy, did that come down. 80% for sure. What was it, like a foot of rain? It was a lot. The whole field was flooded.
Yeah, I took pictures.
Goodness. Yeah, it was crazy. All right. I want you to do thunderstorms and hail, and then we'll go over it. Let me know if you're stuck. Okay, so for thunderstorms, what did you say? What did you say for thunderstorms? Even chance. Okay. And I just put it into a sentence. Since the probability is 50%, there's an even chance. Okay, even chance. All right. What about hail? What about hail? What'd you say, Zach?
Because it's 15% is close to 25%, so it's unlikely.
Yes, very good. That's great. And I just said a 15% chance of hail is unlikely to happen. Oh, forgot the last part of my sentence. Unlikely to happen. Okay. So I'm just trying to show you some different ways that you can write your sentences. The way he did it was perfect. All right. Just make sure it's in a complete sentence and that you use one of your keywords on this section. Any questions? So what happens if you only use one word on your homework? I'm going to count off. I'm going to count off a point for not having a complete sentence. You say, well, it's not English class. Well, I say false. You need to still know how to write a complete sentence, even in math class. All right, so describing likelihood, now example 3. Now here's where we're going to start calculating probabilities. Okay, we have what we call relative frequency. It's a fancy word for we actually do the experiment. Okay, here's where I kind of lost my 6th hour there for a minute. The flipping bottle game where you flip the bottle to see if it lands upright or on its side. How many of you, especially my boys, play that game? And girls, okay? Everybody has. Where you throw it up in the air and you see if you can make it land upright. Okay? Guys, stop. Guys. All right, so you flip a bottle and record the number of times it lands upright and the number of times it lands on its side. And we come up with data. Basically, we're conducting an experiment. So here are your results. Let me go ahead and put it up there on the table. The formula for relative frequency you need to have written down. Make sure you have that. So upright results and on the side results. And here are my tallies. All right, so go ahead and copy down the table. And then we're going to put this into a probability. Right, so now I have to look at what it's asking me for. Is it asking me for the probability that it lands upright or on the side? Okay, well actually let me back up. Is this person very good at the game? No, they're not. I think if I actually had some of you guys do it, it would be like the reverse statistics because I know a lot of you have gotten pretty good at that game, right? Okay, you can make it land upright almost every time. All right, so this person is clearly not very good at it. But that's okay. So based on, listen, you're trying to predict now what the probability is that they're going to land the bottle upright on their next flip. So here's what we do. Probability that it lands upright. Again, it's whatever your targeted outcome is. So how many favorable outcomes did we have in the first experiment? 2. How many total outcomes did we have? 25. Now, this doesn't really mean anything to me. I need it as a percentage so I can see where it falls on the scale. Okay? So change it to a percentage and then use one of your keywords. Is it impossible, unlikely, even chance, likely, or certain? All right, go ahead and write your percentage and then answer the question of likelihood. Okay, so 2 over 25 is what percentage? 8%. So it is unlikely. Let me ask you this. What about 1%? it's still unlikely, okay? So even though it's really, really close to 0, does 1% mean impossible?
No.
Okay. Anybody seen the movie Dumb and Dumber when she says there's 1 in a million chance? And he said, so you're saying there's a chance, right? So unless it's 0, it's not impossible, okay? 1% means just very unlikely. Same thing on the other side with 99%. Is 99% certain?
No.
No, it's just very likely, okay? So on the extreme ends, it has to be either 0 or 100. It's not going to be impossible. All right, example 4, and we're done. On example 4, we just have, hopefully just more of like an application type problem, and we're going to type percent problem into this. All right, that'll be fun. Each turn in a game, you randomly draw a token from a bag and replace it. The table shows the number of times you draw each type of token. How many times can you expect to draw a positive point value in 35 turns? All right, so go ahead and draw that frequency chart real quick. So if you get a +3 or a +1 or a -2, and how many times that happens. Again, this is like an actual experiment. This is something you're actually drawing the tokens to see what your results are. And the table shows those results. Okay, so what I need to do is calculate the probability here based on the information in the table. All right, so what is the probability? What is my targeted probability? Probability of a what? Does anybody know? Don't say it out loud. Try to figure out what goes in parentheses. The problem tells you. How many times can you expect to draw a positive point value? All right, and I abbreviated. All right, that's fine. Okay, just don't use some crazy abbreviation that I have no idea what you're saying. It doesn't look like anything, okay? All right, so a positive point value, that's what I'm looking for. So I need to figure out of how many tries, okay, so what's my favorable over my possible? Well, how many of these outcomes ended up being positive? Don't say it out loud, write it on your paper. How many of these outcomes were positive? That's my favorable, it goes on top. How many is it? 17 over how many total tries? 20. 17 over 20. That doesn't mean a whole lot to me. I need it as a percentage. Go ahead and convert it. What's my percentage? 85%. Okay, so 85% is pretty high. That's great. Looks like I have pretty good chances, like I was just saying, looks like I have pretty good chances of choosing a positive number. However, this was only out of 20 turns. I need to predict out of 35 turns. So what this example is showing us is we can calculate, stop talking. We can calculate a probability, a future probability, based on a current statistic. All right, so based on this information, I can predict how many positive outcomes would come if I actually tried it 35 times. Here's how I do it. The percent equation, A equals P times W. Does that look familiar? It should, okay? Where A is the part, P is the percent, and W is the whole. All right, so here's what you have to figure out. Is 35 describing the total amount or only part of the result? That is the total amount of tries. So that plugs in for which value? W. And when you're plugging a percentage into the percent equation, what must you do first? Change it to a decimal. 0.85, sorry. 0.85 times 35 would give me about how many tries would be expected to be positive. Yeah. Now, is it possible to have 3/4 of a try? No, so I'm just going to round it to about 30. Now, how do I know that I rounded?
Because you got the little squiggly line.
Yes, the approximation symbol shows my readers that I did round to about 30 times. So I used my percentage based on the data that had been collected to predict a future amount that had not happened yet. Guys, this happens all the time in the business world. They use past results to predict future behavior. All right? If in the past, 100% of the time, you forgot to make your bed, what can we predict about the future? You're going to forget to make your bed. Okay? Unless something drastic changes. So, you know that saying, past behavior is the best indicator of future behavior. There's a lot of truth there. And who knew it? That's probability. Okay? So, if you understand that, that's everything you need to know for section 7.1.